Hello viewers, in this video we will see the solution to week 2 assignment 2 for the course Digital Electronic Circuits. First question, consider the following truth tables for addition, multiplication and division operation. So they are given three truth tables. They are given F equal to in terms of A, B, C and D. Now we will see the solution for this. So solutions are our suggestions. These are our suggestions. So kindly spend time in going through the solutions before or after assignment submission for better score in exam. Now coming to the solution. So A, B, C, D 4 variables. So decimal number 0, 1, 2, 3, 4, 5, 6 up to 15, because for 4 variables we will get 16 combinations. So convert this decimal into binary. So 16 combinations are there. Now what is the function f for this particular given function? So how to write that one? So I have taken 3 examples. For serial number 4, a is equal to 0, b equal to 1, c equal to d equal to both 0 zeros. So we will see the function f is 0. So a is equal to 0, b equal to 1, c equal to 0, d equal to 0, f is equal to, because a according to this equation a is equal to 0 here, and b is equal to 1 here, and c is equal to 0 here, and divided by d is equal to 0. So what we will get is 1 multiplied by 0 is 1 dot 0 is 0, 0 plus 0 is 0. So numerator will get 0, denominator is 0, 0 by 0 is 0. So 0 by 0 is 0. So next you can see for serial number 8, a is equal to 1, b, c, d are 0, 0, 0. So now a equal to 1, b and c is 0. So therefore numerator will be 1 here, denominator is 0 because d is equal to 0 here. 1 by 0 is don't care, x. So we will see why it is. So 1 by 0, this is 1 by 0 is x, don't care. So there it is don't care. So now you can see it is don't care. Therefore I put x here, I put 0. For 13th serial decimal number 13, you can see here 1 1 0 1. So a equal to 1, b equal to 1, c equal to 0, d equal to 0. So 1 dot 0 is 0, 1. So 0 plus 1 is equal to 1. So both numerator and denominator are both 1 1. So according to this, if both are 1 1, a bar b is equal to 1. So therefore we have written here 1, we have written output f equal to 1. So likewise you can complete for remaining combinations, input combinations, and then we have formed a truth table. So you must know how to simplify the truth table using Karnaugh map. So if you simplify this one, so you will get a plus bc, the end, this is, you will get a here, and for this group you will get bc. So option D, the answer is option D. Answer is option D, A plus BC. So second question, so if A and B are 2-bit binary numbers and the function y is nothing but A greater than or equal to B, for A greater than B, y is equal to 1, and for remaining it is 0. So what is y expression? We will try to find the solution for this one. So again decimal number, because now a is a naught a1, b is b naught b1. So y we have taken is equal to a greater than or equal to b. So decimal number 0 to 15 again I have taken, because 4 input variables, again 16 combinations are there. Now we'll consider how to write y output for y. So let us consider decimal number 3. You can see here a naught a1 is 0 0, b naught b1 is 1 1. So in this case a is less than b, therefore output y is equal to 0. Consider the 10th one. So in the 10th one, a naught a1 equal to 1 0 and b naught b1 equal to 1 0. So here a is equal to b, therefore for a is equal to b, for a greater than or equal to b, output y is 1. So y is equal to 1. So therefore I put 1 here. So similarly we can complete for the remaining. So for example in the 15th, you can see a equal to b here. So therefore 1. Now here A is greater than B, 1. Again this combination A is greater than B, therefore 1. Again here A is greater than B, 1. So likewise you can complete for the remaining input combinations. And once that is done, you can use Karnaugh map method to find the expressions. So and that expression, so this is one group, and this is second group, and this is the third group, and this is the fourth group. This is the fourth group. So we can, so accordingly we find here option C, option C. So answer is option C. This one. So third one, a logic circuit implements a Boolean function given by some function they have given. So let us try to find what is this third one. For the third one, is it XOR operation or AND operation or XNOR operation or OR operation? So remember, Z is equal, X equal to Z equal to 1 can never occur. So we'll try to see the solution for third one. So for the third one, so it's X, Y, Z. So 0, 1, 2, 3 up to 7. So here we will consider fifth one, the serial number fifth one. Here X equal to Z equal to 1. This does not occur. And similarly here seventh one, X equal to 1, X equal to Z equal to 1. This also will not occur. Whereas these two will occur. These two will occur. Therefore I put a tick mark here, and unknowingly I put a round mark here. So now thing is, what about the F? What about the F? If you look at this, consider F equal to X exclusive XOR operation. If you take XOR operation, so if you take XOR operation, if X equal to Y, if X equal to Y, F equal to 0. Otherwise, F equal to 1. So if you see here X equal to Y, so in this case X equal to Y, therefore F equal to 0. X equal to Y, F equal to 0. In this case, X is not equal to Y, therefore 1. X is not equal to Y, therefore 1. In this case, X equal to Y, therefore equal to 0. So therefore this is nothing but an XOR operation. This is simply nothing but an XOR operation. The answer is option A. So the answer is option A. So we have exclusive OR operation, option A. Fourth one, so they are given circuit diagram. We have to find out the expression for this one. So we'll see the solution for the fourth one. So for the fourth one, so what is there? It's a 4 variable. So if you consider A equal to Y and B equal to W bar and C equal to W bar and D equal to X, and so if you simplify, this is the, we will consider this one. We'll consider this one, and before that one, what I'll do here, go back to the circuit diagram. So according to circuit diagram, let us try to find what is F. What is F? So according to circuit diagram and using the simplification, Karnaugh map simplification, I am finding F equal to W bar X bar Y plus W bar X Y bar, equation 1. Now consider the option D. So why I am consider option D? Because Z is not there. In option D, Z variable Z is not there, because in my equation 1 Z is not there. Therefore I will consider the option D. So I'll trial and error method. A equal to Y, B equal to W bar, C equal to W bar, and D equal to X. So you can see here. So AND gate output AB. So according to this equation, AB is equal to Y X bar. AB equal to, according to this, Y W bar. CD is equal to W bar X, and XOR output. So XOR of these two is, so do XOR operation, and then we are doing simplification. So after simplification, we find that equation 1 and 2 are same. Go through the steps. Go through the simplification steps. So equation 1 is equal to equation 2, option D. Answer is option D. So answer is option D. Fifth one, we'll see the fifth one. So fifth one, so they have given some tabular column for, this is NOR operation, XOR operation, AND operation, XNOR operation. So we'll try to find the answer for the fifth one. So fifth one, so A, B, C, D. So all this, so 0, 0. So this is XNOR operation. Once again I'll show you what is the question here. 0, 0 means XNOR operation, and 0, 1 means 0, 1, 0, 1, 0, 1 means XOR operation, 1, 0 means NAND operation, 1, 1 means XNOR. So now you can see this one. So here all are 0, 0, zeros. AB 0, 0, AB, look at the AB variables 0, 0, 0, 0, 0, 0, 0. So that is nothing but NOR operation. If you look at the next 4, 0, 1, 0, 1, 0, 1, 0, 1 is XOR operation, and the next 4, 1, 0, 1, 0, 1, 0, 1, 0 is NAND operation, and then 1, 1, 1, 1, 1, 1, 1, 1. The last 4 combinations are XNOR operations. So what we'll try to find, so XNOR, X into Y, so we'll complete Z value, so Z value, so accordingly you find out the Z value, so you find out the Z value. So for NOR operation, so we know, so for NOR is NOR operation. So NOR operation of this entire thing, X NOR Y, X NOR Y. What is X? So you substitute for Z, XNOR operation, XOR operation. So remember for XOR operation, so for XOR operation, if both inputs are equal, outputs are 0. So if both inputs are unequal, the outputs are 1. Okay. So that is how we are finding the Z value, and then we use the Karnaugh map simplification. So we will get after simplification we will get B bar x bar y bar plus A x bar y bar, B bar x bar plus A B bar y bar plus A bar B x bar y plus A bar B x y bar. So its answer option. This is option B. Okay. So answer is option B. Okay. Then coming to sixth one. So sixth question, I think I am taking too much time. So sixth question. So what I am trying to do is I am trial and error method. What I am doing, if gate G1 is AND gate and the G2 is NAND gate, so after simplification by applying De Morgan's theorem, what we get is Y is equal to A plus B plus C bar plus D bar. So this is the answer. So sixth one is AND gate and non option B, AND gate and NAND gate. Let us move to seventh one. So for the seventh one, we'll see here for the seventh one, XNOR operation. If A is equal to B is equal to 1, if A is equal to B is equal to 1, we'll get here if A is equal to B, output Y is equal to 1. This is output Y is equal to 1. Y is equal to 1, and if A is not equal to B, Y is equal to 0. So there is a correction. This is output Y. For n odd number of XNOR gates, for example, we will consider n equal to 3, which is odd number. So how many gates we will have? So we will have here 4. So sorry, 3 XOR gates will be there, and therefore we will have 4 inputs, A0, A1, A2, A3. So we have taken odd number of ones for this one particular combination, odd number of ones. Your output Y will be 0. Here also odd number of ones, output Y equal to 0. Here also odd number of ones, this is only 1, so output equal to 0. So here also odd number of ones, output Y is equal to 0. Here also odd number of ones, output Y is equal to 0. And likewise you can take n number of combinations of odd number. So here also odd number of ones, you will get 0. So output Y is equal to 0. 0. Eighth one, the output of the given circuit diagram is y, output y, output is, we'll see here output for the eighth one. It's a simple. So what we find is first AND gate is A, B, C bar, second AND gate output is B, C bar, and the third AND gate is A, B bar. So sum of all these three is the OR gate. So therefore A, B bar, B, C bar, and A, B, C bar. Option D. This is option D. So this is option D. Ninth one, with 5 logic variables, there are dash number of total number of possible logic functions. We will see here. So for n equal to 5, total number of possible logic functions 2 power n. 2 power 5 is 32. So therefore 2 power 32, and that is nothing but, so we have to enter this value 429496. Is it correct? So 4294. Let me verify. Let me know 1 second, please. So 429496. 429496 7300. So what you have to enter is 4294967300. Let us check. 4294967300. 4294967300. That is the answer. So 10th one. So for the 10th one, what we find here is, so initially all are 0, 0, 0, 0. Therefore, you will get initially. So initially we assume that even output is also 1. So for 0, 0, we get output as 1 because this is the NOR gate. Here also we will get output as 1, and then alternately we will be getting 0, 1, 0, 1, 0, 1. So the answer is option D. 11th one. Find the dual of the following expression using Shannon's expansion. So 11th one we will see here. So this is the given function. So dual form is this dot becomes plus here. Rest of here 0 becomes 1. Rest of the things are same. So here this plus becomes dot, and here this dot becomes plus, and this 1 becomes 0. Rest of the things are same. So therefore the answer for this is, we'll go for that one. The answer for that is option A. So option A, you will get here 1, and you will get here 0. Well, let us check here. So we are getting here 1 and 0 here. So here it is 1, here it is 0. Option A. 12th one. So 12th one we'll see here. You can find from the notes. So 12th is option A. Option A. Option A. 12th is option A. 12th is option A, and this is that one. And because of shortage of time, so next question: which gate is used? Which gate is used? So NAND gate is used for it is more efficient in terms of speed and power consumption, and as well as size and cost. So NAND gate is option C. And find the self-dual function among the given functions. 14th question. So 14th, let us see here what are the options they have given. Option A, option B, option C, option D. So for option A, so 2 and 5, what is 2 and 5 here? This 2 and 5, 2 and 5, 2 and 5. So 2 and 5, 2 and 5, 2 is nothing but 0, 1, 0, and 5 is nothing but 1, not 1, mutually exclusive. Similarly for option C, again we have 2 and 5, these are mutually exclusive. And option D, 1 and 6, 0, 0, 1, this is 1, 1, 0. So these two are again mutually exclusive. So these three are not the options. The answer is option B. Option B. So last one, simplify the Boolean function. So this is we'll try to find the answer for this one. So for the given function, put all zeros in the number given 0, 1, 2, and then try to simplify this one. So what I am getting here is this expression I am getting. So which is option B and C both are correct. So for C, this is these two can be combined. These two can be combined to obtain for the option C. So option B and C are correct. Option B and C are correct. I'll put option B. Thank you, viewers.